Hey guys, Miss Milton here. Today we're going to look at division property of exponents. At the end of this video, you should be able to use division property of exponents to simplify exponential expression. Here it says simplify a to the fifth over a squared. What is this saying? Well, remember that we have a to the fifth. That would mean a times a times a times a times a 5 times. A squared is a times a. They're asking us to reduce this. What does this reduce to? Okay, and so we can reduce this by basically canceling out our common factors, and then we'll get a to the third power. Okay, what we can do though, kind of to, instead of writing this out 5 times, 2 times, is this answer ends up being 5 minus 2. See where this has happened? Because we're doing division, we're going to subtract the exponent. The second example, we have h to the negative third over h to the 12th. What's our answer going to be? Well, let's walk through this process first. It says many people mess up this subtraction, especially with negatives, so I've come up with a process that can get rid of that problem. Okay, first, ask yourself these 3 questions. Is everybody happy? Basically, are there any negative exponents? Okay, then make all the negative exponents positive by moving them. Okay, so here we do have a negative exponent that's unhappy. Let's make it positive by moving it. So 1 over h12, and we move that down to the bottom, so plus 3. Okay, so for this problem, we'd have 1 over h to the 15th. Okay, the second thing you'd ask you is, if everybody's happy, where are there more of the base? Okay, where are there more exponents? Okay, and then you say how many more? The answer to this question is the exponent. This is never negative. Right? Because in our final answer, we can't have a negative exponent. So let's look at this. Simplify this expression. C over 9, or c to the 9th power over c to the 15th. So I say, is everybody happy? Yes. Where's there more? There's more on the bottom. Okay, so I'm going to move this to the bottom. And it's 1 over c to the 15 minus 9, which gives us 6. 1 over c to the 6th power. Number 2, do the same thing. Is everybody happy? No, nobody's happy. So let's change that. I move these, move it down, move it up. P to the 8th over p to the 3rd. All right, is everybody happy? Yes. Where are there more? There are more up top. So I'm going to subtract from the top. And that gives me p to the 5th power. Number 3, is everybody happy? No, it's negative, not happy. So I have 1 over m to the 6th. I move that 3 down, and now it's positive. 1 over m to the 9th. Number 4, we have 2 bases now. Okay, so remember, we're keeping the c's with the c's and the d's with the d's. Is everybody happy? Yes. I'm going to help remind myself that that is an exponent 1. And so now I'll say, okay, with the c's, there are more c's in the top. So on the top, I'm going to do 7 minus 1. With the d's, there are more d's in the denominator. So I'm going to move that 3 down, minus 3. So my final answer gives me c to the 6th over d to the 5th. Here's a few tougher ones. What do you do when you have a fraction raised to a power? Okay, the exponent gets put with everything in the numerator and the denominator. So remember that every number has an exponent, right? And so when we have this 3, we distribute it inside the parentheses just like we did when we raised the power to a power. So we have 2 to the 3rd power over 3 to the 3rd power, which gives us 8 over 27. Okay, number 2. We have 4 squared over 8 x to the 6th. And so that is 16 over x to the 6th. For number 3, I notice inside here I have a negative exponent. I'm going to move this up before I distribute. I feel like it's going to make it easier for me. X to the 3rd, y, z to the 2nd. Okay, and now I'm going to take this forward and I'm going to distribute it to each term inside. And that will give me x to the 12th power, y to the 4th power, z to the 8th power. Number 4, again, I notice negative exponent with the n. I'm going to move that down to make it positive before I distribute my exponent. 3m cubed over 2 n to the 4th p to the 6th. Okay, and now I'm going to take that exponent 2 and distribute it to everything inside. I'm going to distribute to that exponent, that's except all of them. So I have 3 squared m to the 6th over 2 squared n to the 8th p to the 12th. And then I simplify. 3 squared is 9. M to the 6th over 4 n to the 8th p to the 12th. All right, number 5. Here I have a negative exponent. As I distribute this negative exponent, I have 3 to the negative 2 over 4 to the negative 2. These are both negative, so they both need to move. So now I'll have 4 squared over 3 squared, which is 16 over 9. Okay. With this negative 1, you saw what happened last time, that the numerator and the denominator flipped and we had to square it. Well, here, all these are happy, right? And it's just negative 1. What this is going to do is it's going to flip our fraction. We'll have s over 2r. Okay, or 2 to the negative 1, r negative 1 over s to negative 1. And all of those negatives will want to move. Number 7. There's a bunch I could do, but here's what I see. This negative exponent, I'll just do it. This negative exponent, when I multiply it by these negative exponents inside, will make them positive, so they'll stay where they need to be. I'm going to move this to the bottom. Okay, so we'll see what happens here. That becomes y to the negative 2, z to the negative 4. And then with that, I'm going to multiply everything by negative 3. Okay, everything. And so that gives me x to the 15, and notice that it's positive. It gets to stay where it's at. Y to the 6th, z to the 12th. Now everything's positive. It's where it's going to be. Here inside of this parentheses, I got a few things that can simplify. So I'm going to simplify the parentheses, before I go to the exponents. So I have 4 over 2. That simplifies to give me 2 over 1. I have a to the 5th over a to the 1st power. Okay, so I see that I'm going to subtract the 1 from the top. A to the 4th. I have b to the negative 3rd and b to the 10th. So this negative 3 is not happy. Move it to the bottom. That gives me b to the 10th in the bottom, in the denominator. Okay, and so now I've simplified that, and I'm going to square it. So I'll make sure I got that has a 1 there, distribute to each of the terms. So that gives me 2 squared, which is 4, a to the 4th times 2, which is a to the 8th, b to the 10th times 2, which is b to the 20th power. Okay, believe me that this problem can go on for a very long time, taking up a lot of paper space if you do this in an inefficient way. Simplify the parentheses, make them positive, distribute. We got it done in 2 lines. Okay, number 9. All right, so we only have this distributed exponent in the denominator. So I'm going to do that. I have 9k to the 3rd, p squared. And in the denominator, I have 27, that's 3 to the 3rd power, k to the 3rd, p to the 9th. And now I go through and I answer the questions. 9 over 27 gives me 1 over 3. K to the 3rd, k to the 3rd, they're the same. it's going to end up being k to the 0 power, which is 1. Okay. With our p's, they're all happy. Where's the most of them? At the bottom. So I'm going to move this 2 to the bottom. It gives me p to the 7th power. Boom, done. Scientific notation. How does this work with scientific notation? The same way. Okay, we take like terms and we divide them by each other. So our numbers 7.5 and 2.5, divide the a values. 7.5 divided by 2.5 is 3. 10 to the 4th over 10 to the 6th. Here's the thing with the exponents. Before we were saying, hey, choose the one that's larger. But with scientific notation, you're always going to subtract the bottom from the top because we can have negative exponents. So this will give us 10 to the negative 2nd. Okay. I said divide, and I should have said simplify. That'd be better to say simplify. Okay, so here we have 4.2 over 8. Or sorry, 4.2 times 10 to the negative 7 over 8 times 10 to the 3rd. So with 4.2 and 8, I guess I can simplify that. 4.2 divided by 8 should be something like 0.6. Look at me not being right. 0.525. All right, so that gives me 0.525. And then I'm going to subtract the bottom from the top, so times 10 to the negative 10th. Okay, and so I need to move this to the right to make it scientific notation. 5.25. I made decimal place 1 place bigger, so I need to make my exponent 1 place smaller. Okay, or if you're doing the nagging exponent, this said move to the left 10 times, and then I move to the right and it'll say, well, move to the left 11 times now, right? All right, so that's the division properties of exponents. Yeah. See ya.